Hi everyone, welcome to part 3 of the PtyRAD Summer School tutorial series. In this video, I'll walk you through how to run PtyRAD locally on your machine using VS Code and the command line. I will also briefly show how to run it on Sci server, and finally, we'll look at how to visualize the reconstruction results in ImageJ. Let's start with running PtyRAD locally. First, launch VS Code on your computer. Open the folder where your PtyRAD project is located. This folder should have 4 subfolders. Data, where your .raw or HDF5 files are stored. The params folder contains your .yml parameter files. Scripts, where Jupyter notebooks and possibly HPC submission files go. Once you run your first reconstruction, output folder will be automatically created in this directory as well. For this demo, I'll be using the twisted bilayer tungsten diselenide dataset from the 2024 science paper. The first step is to open the .yml parameter file and make sure everything is set correctly. The most important settings to check are the experimental parameters, like the beam energy, convergence angle, defocus, and scan step size. Also, if you are doing a regular multi-slice, make sure the hypertune flag is set to false. The rest of the parameters are explained in earlier videos, and you can also find full details on the PtyRAD documentation website. Towards the end of the .yml file, you will also need to set the name of the output directory, how often we would want to save the results, and actually what results would you like to save in the output folder. Once we are happy with the .yml file, we can open the Run PtyRAD Quick Example Python notebook. This notebook only has 3 cells. The first cell sets the working directory to the PtyRAD project folder. The second cell loads the .yml file and sets up the text logger. When you run this cell, dataset will be loaded to your GPU. That usually takes a few seconds. In the output of the cell, you will see logger updating live. It will also print out system details like GPU info, so you can confirm everything is running on the right hardware. If no error shows up, you can move on to the final cell, which actually runs the reconstruction. Again, the logger will keep updating live as it processes the data. I have now stopped the execution of the cell in order to show how to run PtyRAD from the command line. First thing that we want to do in the terminal, we want to activate the PtyRAD conda environment. Once PtyRAD has been activated, we'd like to change the directory to the folder with our PtyRAD project. Last step is to actually make the PtyRAD run the parameter file. In order to do that, we write PtyRAD run -- params path, and now we need to put the path to the parameter file. Now we can hit enter, run this line, and you will see exactly same updates of the text logger file. Once we know how to run PtyRAD on a local machine, running it on Sci server is very straightforward. After you create an account and join the group invitation and get access to the computational resources, you can create a container over here and name it PtyRAD by double clicking it will open in a Jupyter Lab environment. After installing the PtyRAD with pip install, we using the browser, we go to um, the scripts folder in our PtyRAD project folder and open the quick example Python node. The biggest change here is compared to the local machine is that we have to change the relative working directory. The second cell remains the same, and it also runs without any problem. Now we can run our Tycho solver, and as you can tell, now the output folder has been created. After letting the code run for some time, we can open the output folder and visualize the results. Here we open image.j, and we can drag and drop the object face Z stack after 200 iterations. And by dragging the slider, we can access different slices within the Z stack. As you can see, PtyRAD does a great job at reconstructing the twisted bilayer sample.